I am Anil Kumar. Welcome to my online classes. Let me thank all the students who are taking the advantage of these classes. You can always register by sending an email to the address given here. We are taking online classes for all the students in school up to grade 12. This particular video is for our grade 4 and grade 5 students. We have actually discussed about patterns and pattern rules, and now we are at an important juncture of solving word problems using pattern rules. So here we'll discuss 6 important questions. They will help you to understand all the concepts. So let's go through them one by one. I'll also encourage the students to actually pause the video after reading the questions, solve them yourself, and then look into my solutions in this particular video. Perfect. So we'll try to read the questions and capture the information as we move along. That should help you to find a strategy to solve. And once you solve, then look into my solutions. Perfect. Okay. So let's begin with the very first question, which is in a 15-kilometer marathon race, first water station is at 3 kilometer mark. Then, after every 1.5 kilometer, there is a water station. How many water stations are there in total? So when you read such a question, you should see what you need to figure out. We need to find how many water stations are there. Now we should see how can we figure this out. Well, we are given that there is a 15-kilometer marathon race. First water station is at 3 kilometer mark, right? Then after every 1.5. So that is how the pattern grows. So you can think about in your mind writing like this, that the first mark is at 3 kilometers, and then what do? We add 1.5, right? We add 1.5 and get the next one, which is at 4.5. And then again, we add 1.5 to get the next one, which is how much? So when you add zero point 0.5, it becomes 5, and then 1 makes it 6, 6.0. And then again, this pattern is being followed, correct? Keep on adding 1.5 and you'll get a pattern until you hit the mark, which is 15. Now the idea is how many such marks are there? That means how many terms are there, right? So figure out the number of terms. Is that clear to you? So that is how you're going to solve this particular question. Now, let's look into question number 2, which is Anna and Shruti ran a 10-kilometer race. Anna ran first kilometer in 6 minutes, and each kilometer after that took 1 minute longer to run than the previous kilometer. Shruti ran at a constant speed, taking 10 minutes for every kilometer. Who completes the race earlier? So shorter the time, faster the person. So completes the race earlier. So we are comparing. So Shruti is running at a constant speed. Anna's speed is not constant. We have a 10-kilometer race. The first kilometer in 6 minutes, and each kilometer thereafter took 1 minute extra. That means you have to do a lot of working to figure out how much time Anna took. As far as Shruti is concerned, we know 10 minutes and we also know 10 kilometers, and that gives you total number of minutes. So for Shruti, it is 10 times 10, and that gives you 100 minutes, correct? Now we have to find how much did Anna run. Okay, so 10 kilometers. So you need to have 10 terms, correct? So you need to have 10 terms. First kilometer she ran at 6, and then she added 1 minute more each time. So 6 plus 7 plus 8 plus 9 plus so on, correct? And how many should you have such terms? You're looking for 10 terms. Do you see that? Again, you're looking for 10 terms. You need to find the sum and then compare this sum with 100 minutes. If it is less, Anna is faster. If it is more, Shruti is faster. Correct? That is the strategy. Question number 3. Cindy wants to save $500 for a new dress. She has two options: save $10 each day or save 50 on the first day and on each day after that, double the saving amount, right? Which method is better for Cindy to get the dress earlier? Again, apply the strategy, correct? So we have a constant term 10 each day. So $500 you want, when you divide by 10, what do you get? Right? When you're doing 10 each day, then in that case, you take 50 days to do it. Okay, so you take such a long time, right? So there is some typing error, I think, and saves 50 on the first day, and on each day it is double, right? So on the other hand, she is doing like this: 50 on the first day, and then double the amount, right? Uh, so I think there is a typing error here. So what we have to do is this amount should have been 50. So let me just change this. 50 each day. Not 10, 50 each day. And in that case, what really happens is she takes how much time? She will take 500 divided by 50, it is 10 days. Correct? On the other hand, this amount on the first day should not be 50. It has to be much, much lesser. Let's give it only $1 and then we'll work it out. Okay, so we say in this particular case, this amount here is $1. So $1 on the first day, and on each day after that, double the same amount of the previous day. Do you see? That is how it is going to do. Which method is better for Cindy? That is what you need to figure out. Okay, so I hope that is clear now. So now the question is that is it better to save $50 each day, or you save like this: $1, and the next day you add $2, then you add $4, then you add $8, then you add $16 and $32, and so on? Which option is better? I hope that is clear now, right? Sorry for this typing error. Now let's move on and take question number 4. In question number 4, we have a pattern and says describe the pattern 359 17 33, and so on, right? So this pattern increases and so on. Make a word problem for the above pattern, right? So it could be similar to what we are discussing. So you need to make a word problem from which will help you to follow this particular pattern and solve. Now, two questions are: what number between 500 and 600 lie in this pattern? So you have to include more terms and see which number between 500 and 600 lie in this particular pattern. And part B is explain why there will not be any number between 600 and 1000 for this pattern, correct? See, it is really growing very, very fast. So there will be so many numbers skipped. So you have to just check this out, okay? Let's move on and see the other two questions, which are question number 5 and 6. Now these are based on playing cards. Anil mixes and then places all the above 13 cards in a row with face down. So we have these cards with us. So these we have selected the cards of the suit for hearts. A is 1, which is 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. These are the 13 cards. So Anil mixes, then places all the 13 cards in a row with face down, right? So when we have face down, you cannot read the card. So the number is hidden. The value of the card is hidden. Okay. The value of the card is not visible. Clear? He flips every third card. So when you flip every third card, you can see the value of that card. So he flips every third card. Then in the second round, he flips second card. Amita enters the room after the second round of flipping the cards. Now, there are two questions based on this. First one is, value of how many cards can Amita see? And the second one is, value of how many cards has Anil seen? So there are two questions here. One, value of how many cards did Amita see? That is after the cards have been flipped in the second round also. And the value of many cards with how many cards did Anil see? He saw the value even after the first flipping, so that makes a difference. Okay. Question number 6 is related, but this time we are complicated by taking all the cards in a deck. Question here is, there are 52 cards in a standard deck of cards. Anil mixes and then places all the 52 cards in a row with face down. The value of the cards is not visible. He flips every third card first. Then, in the second round, he flips every second card. Amita enters the room after the second round of flipping the cards. Amita can now see value of some cards. Anil has seen more cards than Amita, right? Explain why. You know that. Explain it. And the second part of this question is, how many cards did Anil see? How many more cards did Anil see? So that is important. How many more cards did Anil see than Amita? Correct? These are the questions for you. Now you can actually answer the questions and then watch my solutions, right? You can pause the video at this stage. Now let's see how to answer such word problems. They are actually very difficult. Now let's understand the strategies. I gave you a strategy while we were actually reading the questions, and here we'll provide you a couple of solutions. So one solution in the form of a T chart is given to you. Let's read the question once again. It says, in a 15-kilometer marathon race, first water station is at 3 kilometers. So when I'm making a T chart, see what am I doing? I'm putting the marks here, right? We read the question earlier, so we know kind of what is expected. So in a 15-kilometer marathon, so I would like to go to 15, but how many marks we are interested in. That is what we are putting on the top of the table. So in a 15-kilometer marathon race, first water station is at 3 kilometer mark. Then every 1.5 kilometer there is a water station. How many water stations are there? We want number of water stations, correct? That is what we want. And that depends on, we'll call them the mark, the positions, where the water stations are placed. So we will write down the positions in a sequence, 1, 2, whatever. And then let's talk about the interval. Where are the water stations? First water station is there at 3.5 kilometers, 3 kilometers, correct? So that is the first one at 3 kilometers. And then what happens? Well, every 1.5 kilometers thereafter, that means I have to add 1.5 to get the next term. So on 3, I will add 1.5 to get the next term, and that makes it 4.5, correct? So for convenience, what I'm doing is I have added intervals here where I've written the numbers to be added. It is 1.5 number which is going to be added each time to the previous term, correct? So this number 1.5, I have an additional row which helps to figure this out. And now I can do the addition. I will do 3 plus 1.5, which gives me 4.5. 4.5 plus 1.5 gives me 6. 6 plus 1.5 gives me 7.5. Then again, when we add 1.5, we get 9. And then again, adding 1.5, we get 10.5. And then 12. And then 13.5. And we get finally the mark at 15, where the race ends. So this is the end of the race, correct? Since it was a 15-kilometer marathon. Now you can count. You can count how many terms. We have 9 terms. Do you see that? And that is how we get our answer. 9 stations. Perfect. Some of you can also do it like this. You can start your pattern at 3 and then keep on adding 1.5. So let me write this as 3 plus 1.5, which is 4.5, and then add 1.5. You get 6, and then add 1.5 more, and keep on doing this, and then you can ultimately count when do you reach 15, correct? That is another way of doing the same thing. So you can count how many water stations are there. Number 1, 2, 3, 4, 5, 6, 7, 8, and 1, 9. So the last one is the ninth water station. That is another way of doing it. This is what we say using pattern rules. Do you understand the strategy now? So we are following two strategies here. One, you can make a pattern. The other one, which we did here, is called T-chart. So these two rules will be followed to answer all these questions. Now let's take the next one, which is here. Anna and Shruti ran a 10-kilometer race. The important thing is 10-kilometer race. Anna ran the first kilometer in 6 minutes, and each kilometer after that 1 minute longer she took to run, right, than the previous kilometer. Shruti ran at a constant speed of 10 kilometers or 10 minutes per kilometer, right, for every kilometer. Who completed the race? Well, for Shruti, we are given very clearly that she is constantly running at 10 minutes so per kilometer. So for Shruti, you can write down very clearly that Shruti took how much? 10 minutes into 10 kilometers, right? So definitely 10 minutes per kilometer, right? We say 10 minutes per kilometer. So for 10 kilometers, she had to take 100 minutes, correct? So we know that part, and I wrote this number 100 at the end of 10th kilometer for Shruti. But we need to calculate for Anna. That is complicated. So we made the whole table to figure out what did Anna do, right? So for Anna, let's figure it out. We know that the race is 10 kilometers, so we have 10 terms. So these are your 10 terms, which says first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Now we are given first kilometer she ran in 6 minutes, second in 7 minutes. So in all, 6 plus 7 is 13. So you have to add them up, correct? You have to add them up as you move along. At the end of second kilometer, it took her 13 minutes, and then she took 8 more minutes, 21 minutes in all, 9 more minutes, 30 minutes in all, 10 more minutes, 40 in all, 11 more minutes, 15 in all, 12 more minutes, 63 in all, 13 more minutes, 76 in all, 14 more minutes, 90 in all, 15 more minutes, and 105. That means Anna took 5 extra minutes. So Shruti won, right? So we have Shruti won by 5 minutes, correct? As Anna took 105 minutes, and that is how we could answer this particular question. So I hope the strategy is clear. Let's take the next question here, which is Cindy wants to save $500 for the new dress. She has two options. First option is saving 50 each day. Clearly, when you do 50 each day, she will take 10 days to save for $500. So that is clear. So we just make this $500 on the 10th day in our table, which is very similar to the very first solution. Is that clear to you? Now, how is the saving goes for the second option, which is save $1 on the first day, and on each day after that, double the saving amount of the day. So that is what we are doing. So what we are doing is we have each day. So these are your days, and we don't know how many is she going to take, but she starts with $1. Next day she adds two more. So basically at the end of second day she has $3. 1 plus 2, right? That is how we'll do. Then she is adding 4, so 3 plus 4 is 7, and then we have 7 plus 8, and then we have to add 15 and 16, and likewise the atom moves. And what you notice here is that she has $511 on the ninth day itself. So a day earlier Cindy is able to save the money. So doubling has a lot more power, and it goes very fast, as you can see in this particular pattern. So the numbers will be 1, 3, 7, 15, 31, 63, 127, 255, 511. So she got in 9 days. So definitely double the payment is better. as 500 is saved a day earlier as shown above. Is that clear to you, right? Now this is a very interesting pattern. You'll find the numbers, your times 2 each time, right? So remember this, we are doing times 2 each previous saving. Is that clear? So we are doubling, right? So that means we have to do something with 2, and then we have 2 times 2, and then we have 2 times 2 times 2, and then we have 2 times 2 times 2 times 2, and so on, right? So these numbers are 2, 4, 8, 16, and so on. Do you see these numbers here? And when you add them up, what numbers are you getting? Notice these numbers also, very important to notice. See how they are interestingly linked. So every number here is just total is one less. Do you see total is one less than what is going to be added the next day? So the every day the amount doubles, and it is actually, that is how it grows very fast. Is it clear to you? So the saving is just less than a double. Okay. Now let's take the next rule. Now what I have done here is that this doubling amount is a very important thing. So we took this pattern as such. Describe the pattern 3, 5, 9, 17, 13. Let me add more elements to this, and you to add this. See how it grows, correct? You will notice this pattern is very similar to something which we have seen here, correct? 3, 7, 15. Do you see that? So 3, 5, 9, 17. They are kind of similar over slight variation. So first question here is, make a word problem for the above pattern. So it could be similar to the previous one, and now we have two parts to this. So let's call them as part C and D. What number between 500 and 600 lie in this pattern? To check this out, we have to really extend the pattern, right? So first part is extend the pattern. How will you extend the pattern? Think about it. Now the second question is, explain why there will not be any number between 600 and 1000 for this particular pattern. It is jumping many numbers in between. It jumps from 500 to more than 1000. Do you see that? Okay, so let's see how the pattern grows. So as such, we will just write the term numbers on the top and begin with our pattern. We have 3, 5, 9, 17, 33. Let's see how does it grow. So we see that from 3 to 5, there's a jump of 2, and then there's a jump of 4, and then there's a jump of 8, and then 16. So what are we doing? Well, every time we are adding 2 more previous time, right? So it is double. So we are adding double previous amount. Let me say number this time. So next time, what do we do to get the next term? What do we do to get the next term? How is this pattern growing? You have to multiply the previous one by twice the amount. So in this case, 32 and then 64, right? This 128. Well, another thing which you see, the relation like this. Do you see that? So that also helps to do the addition. And then 256, right? And then 512, and then 1024. Like this, you have to multiply the previous numbers which are being added. And once you do that, then you can actually add the number and get your result. 17 plus 16 is 33. So we know this now works. And then you add 32, you get 65. Then you add 64, you get 128. And then when you add, what you get here is 1 higher than the previous one. So it should be 257, as you can see. And when you do this, you get 513. Now as you get 513, you have hit the first solution, which is the number between 500 and 600. Do you see that? So ninth term will be 513. But when you add the next one, which is 512, you'll get a number here, which is going to be 1025. Do you see that? So clearly, what we are getting here is a number which has jumped all the 600s and 700s. And that is how you could explain this particular solution. But I hope with this you understand the strategy that when you double, you actually jump many, many numbers. Correct? Now let's take the last two questions which are based on the playing cards. So some students may not know what playing cards are, and therefore I've shown them here. This is a deck of cards which have 52 cards, 4 suits, right? You have hearts, spades, diamonds, and clubs. So this is all hearts, correct? Shown to you, 13 of each kind. Anil mixes and places all the above cards, which are these 13 cards, all the above 13 cards, in a row with face down. So when I say face down, that means you cannot see the value of the card, right? At present, you can say it is King of Hearts, but I put it the other way, you cannot see that. So that is face down, okay? The value of the card is not seen because it is put face down. Now the question starts here. He flips every third card. He flips every third card first. Then, in the second round, he flips every second card. Amita enters the room after the second round of flipping of the cards, right? She did not see what happened in the first round. Okay. Value of how many cards can Amita see and value of how many cards has Anil seen. So these are the two questions based on the scenario. You need to answer them. Okay, how do we do it? We take help of this table and this is very useful to understand. So make a table to organize your values here. So we have 13 cards, so we have these numbers 1 to 13. They are placed, right, mixed up but placed, 13 cards. So let's talk about flipping. So when we say every third card, so that means these are the cards 3, 6, 9 and 12 which are flipped. So once you flip them, you can see the face. So I wrote the face for these cards. Now the second round starts. In the second round, we are flipping every second card. So now we are flipping every second card. So these are the cards which will be flipped, the even numbers this time. Okay. So if it was already flipped, in that case, you cannot see the face, right? That's the whole idea. So see what happens. Now, first card, number 2, is flipped, and so you could see that card. Fourth is flipped, okay, but 6 was already flipped, so it has been closed. So C is for closing. Do you see that? And so you see how it changes. So what you notice here, that the cards which are at position 6 and at position 12, they were closed. So these were the cards which were not seen by Amita. So Amita could only see these cards which are 3 of these, and those 3 cards were open, right? So those are the cards which Amita saw. As far as Anil is concerned, he also saw in the previous turn these cards which were not seen by Amita. So there were 2 additional cards which Anil saw, and those 2 cards are these ones, correct? Because they were flipped twice, Amita could not see. Does it make sense to you? So 2 extra cards Anil could see. So from here we know our answer. Amita saw 1, 2, 3, 4, 5, 6 cards, and Anil saw 2 additional, that means 8 cards. Now that brings us to the last question, which is based on the observation we did just now. Question is, there are 52 cards in a standard deck of cards. Anil mixes and then places all the 52 cards in a row with face down, all 52 face down. The value of the cards is not seen. He flips every third card. Then the second round, he flips every second card. Amita enters the room after the second round of flipping the cards. Amita can now see some cards. Anil has seen more cards, correct? Because some cards were flipped twice. Then Amita, explain why. That is the first question which I think you know how to answer. The second question here is, how many more cards did Anil see? That is interesting. So think about it and then answer. Well, of course, what we need to do is 2 times 3 is 6. So every card on the 6th position was flipped twice. These are the cards which Amita did not see. How many were there? Well, we'll go with the multiples of 6 as shown here. 6, 12, 18, 24, 30, 36, 42 and 48 are the card numbers which Amita could not see, but Anil saw after the first flip. In the second flip, they were again turned, flipped over, so Amita could not see. So that is how we can answer the question. Anil saw 8 extra cards than Amita. So I hope that really helps and you understand the strategies learned during our classes. Now, with that, we'll have some more quiz test questions on word problems will prepare you better and move on to the next unit. I hope that makes sense. Feel free to join my classes. If you have questions, feel free to write down your questions and suggestions. Thanks for your time and all the best.